Alright, Unit 8, Subsection 1, Antiderivatives, Part 2. Integrals involving trig and logs. Please recall these basic derivatives from the trigonometry and logarithm units. So, the derivative of sine x was cos x. The derivative of cos x was negative sine x. Now, how I like to do this, and you'll see this kind of scratched in the notes coming up, I usually do this. So, sine x, okay, the derivative is cos x. So then the integral would just be the other way. So the integral of cos x would be sine x. And then, of course, you go cos x. The integral of cos is negative sine. Okay, so the derivative of cos is negative sine. So the integral of negative sine is positive cos. So, of course, the integral of positive sine would be negative cos. Anyways, that's just a little trick that I like to use, but you can do whatever. Okay, so remember the derivative of e to the x was just e to the x. That's kind of a crazy one. Okay, and then the derivative of ln x is 1 over x. Now this one's a special one because that's the derivative. But remember back in the logs unit we talked about the derivative of d dx, the derivative of ln absolute x. Okay, also equaling 1 over x. Well, that's important. We said that's worth remembering at the time. Well, that's important because when we have a single x on the bottom, the integral of that is going to be the absolute x. Okay, so we'll talk about that here at length shortly. Okay, now, it's important to understand these are some of the basic formulas that will be useful. Please remember that any formula, and especially from trig, because there was a lot of formulas in trig, any formula can be used on the upcoming assessments. And you have a formula sheet, so it's not really that big a deal. Also recall from previous units that the chain rule still applies with all of the above functions. For now, when that comes up, we're going to deal with the chain rule on a case-by-case basis, okay, using inspection to figure out what the integral has to be. There will be more formal rules in Part 4. Okay, so first up, so find the antiderivative of the following on the interval 0 to infinity. Don't worry about these interval things. They're really not that important. It's just gives us some kind of an idea of where the function is. So not to worry. So remember the integral of sine. Okay, so the integral of sine x. Okay, so let's go back up to my little chart here. So the integral of sine x, oh, look, that's going to be negative cos x. So negative cos x plus c. Okay, there we go. Next up, sine 3x. Now, here's the funny thing about 3x. Now, I know the exponent hasn't been raised, but this guy here, so integral of sine 3x, so that's going to be negative cos x, but, pardon me, funny, negative cos 3x. But when I take the derivative of this, okay, we're going to get positive sine 3x, which is great, but then we'd have to chain rule the 3x to get an extra 3. So we know then that we're going to have this extra 3 that we have to get rid of. So we have to times by the reciprocal of what the chain rule would have been. So times by the 1/3 and then plus c. So we end up with negative 1/3 cos 3x plus c. Wow, that was kind of tricky, wasn't it? But if we take the derivative of this, look what happens. So the derivative of negative cos is sine. So sine 3x. Now, of course, we still have this third in front. Okay, derivative of cos was negative sine, so the two negatives canceled. Here, let's put them back in. So negative 1/3, then negative sine 3x. Okay, and then we have to times by the chain rule, so we get an extra 3 out of that. Well, the two negatives cancel, the 1/3 cancels with the 3, and you end up with plus 3 sine x, which is exactly what we're supposed to get. So remember, chain rule on this one would give us a 3, so we have to get rid of that 3 by multiplying by a third. Okay, let's try this again with cosine. So the integral of cosine, okay, so remember sine is cos, okay, and then cosine is negative sine. Okay, so the integral of cos, so going up, that's just sine x. So that is sine x plus c. Okay, all there is to it. Now, chain rule again, cos 5x. Okay, so if I take the integral of this, okay, so that's just going to be sine of 5x. Now, if I just left it like that, if I took the derivative of this, I would get cos 5x times 5. Oh, well, wait a sec. I don't want 5 cos 5x. I just want cos 5x. So we have to multiply by the reciprocal of the chain rule. So the chain rule would have given us a 5, so we times by 1/5 plus c. So this is 1/5 sine 5x plus c. Okay, if I take the derivative of this, okay, so 1/5 derivative of sine is cos, so 1/5 cos 5x, and then the 5x chain rules out a 5, and then the 5 and the 1/5 cancel. So we end up with the cos 5x. Great. Don't worry, we'll get the hang of it. It's not a problem. Number 2. Okay, so find the antiderivative of these ones. So, oh, look, we have a cos and a sine at the same time. So I'm just going to write that over here. So sine x, the derivative is cos x. Cos x, derivative is negative sine x. Okay, so if I want the antiderivative, so capital F of x, so cos x, the derivative or integral of cos x is just plain old sine x. Okay, and then, oh, look, we've got a negative sine x. Hey, that's just cos. So that's going to be plus cos x plus c. Okay, we don't have to worry about chain rules or anything for that one. So that is our final answer. Okay, next one up. Okay, so integral of sine x. Okay, so if it's just sine x, then it's negative cos. So negative cos x. And then, oh, look, this guy here, we could have rewritten as plus x to the negative 3. Interesting. Okay, so we raise the exponent by 1. Okay, so that's going to be x to the negative 2, and then multiply by the reciprocal of that exponent. So the reciprocal of negative 2 is negative 1/2. Okay, so that's going to... Okay, plus, so that's going to be negative cos x minus 1/2 x to the negative 2 plus c. Well, of course, we don't want to leave the x to the negative 2 there, so that's just negative cos x minus 1 over 2x squared plus c. And there you have it. So again, it is not necessary, but if you want to check your answer, you certainly can. So if we take the derivative of this, so the derivative of negative cos, okay, derivative of cos is negative sine, so that would be negative sine x. Okay, so that's where the sine x comes from. And then this guy, that would be negative 1/2 x to the negative 2, so the 2 comes down. Okay, so you get negative 2 times negative 1/2 x to the negative 3. Okay, well, negative 2 times negative a half is plus 1. So you get sine x plus 1 over x to the positive 3. And hey, that's the original question there, so you know you're right. If you check it like that, you'll know you're right before I do, which is kind of nice. Okay, so number 3, find the antiderivative of these things with the e to the x's. Wow. Now remember, if the derivative of e to the x is e to the x, the integral of e to the x is e to the x plus c. Okay, so it's going to be the same thing. The only thing we have to worry about is the chain rule part. So capital F of x, so this is going to be negative 3 e to the negative x. Now, that would have chain ruled out a negative, so a negative 1, so we have to divide by the reciprocal of negative 1. Well, negative 1 is kind of funny because the reciprocal of negative 1 is negative 1. Okay, this next one I'll show it a little better. Okay, so we have 6e to the 2x, but that would have chain ruled out a 2, so we have to times by the reciprocal of 2, so that would be a half. Okay, plus c. Now, of course, we take those chain rule parts and we just combine them in. So the negative 1 and the negative 3 makes 3e to the negative x plus. Now the 6 and the half go together, making 3e to the 2x plus c. Okay, so there's our final answer. Now we can check to make sure that works, because if I take the derivative of this, okay, look what happens. We get 3e to the negative x times the chain rule, which is negative 1. Right? The derivative of negative x is negative 1. Plus 3e to the 2x. Remember, the derivative of e to the x is e to the x. So the derivative of e to the 2x is e to the 2x. Okay, but we chain rule out a 2. And the derivative of c is just 0. It never worked out. Okay, so the negative and the 3 went together. So negative 3e to the negative x plus 3 and 2 make 6 e to the 2x. And if you have a look at that, that is our question again, so we know we did it right. All right, you don't have to do that all the time. You don't have to do that any of the time. It's just, it is one of those handy things to do. All right, so number 4, find the antiderivative of this stuff. Okay, so one thing you're going to notice very, very quickly is having an x on the bottom, an x squared, we're going to write that as x to the negative 2. We're not going to do that with the 1. And I'll show you why just once so you can kind of see what's going on. Okay, so if we do that, so that's 2x to the negative 2. And let's do that for this one too, 5x to the negative 1. Okay, plus x. So the rule is to raise the exponent by 1. So this is going to be negative 2, raise the exponent by 1. So negative 2 plus 1 is negative 1. Okay, we multiply by the reciprocal, so that's just negative 1. Minus. See, if I raise the exponent by 1 here, negative 1 plus 1 is 5x to the 0. Okay, and then the reciprocal of 0 is times 1 over 0. Oh, and that doesn't work. That's undefined. So there's got to be something different with the over x's. Okay, so that's why we don't do that for the over single x part. Remember, that is where the ln function comes in. Okay, so let's try this again. Negative 2, we're going to write that just like we normally would with the exponent. To the negative 2, the negative 5 over x we're going to leave because we're going to recognize that that's going to give a ln function, and then plus x. Okay, so that's just rewriting the original. Okay, so if I want the antiderivative, okay, so we raise the exponent by 1. So negative or 2 to the negative 1, times the reciprocal, which is just negative 1. Okay, now the integral of 1 over x is just ln x. So the 5 just comes out. So 5, and then we got 1 over x, so that is ln x. Now technically, that is an absolute value for integrals. Okay, and then we have plus x raised the exponent by 1 multiplied by the reciprocal. So we end up with f of x being negative 2, x to the negative 1, so that's negative 2 over x, minus 5 ln x, okay, plus 1/2 x squared. Okay, and that's our antiderivative. Okay, last one. Well, not quite the last one, but close to the last one. Okay, so we have cos x plus 1 over x squared. So, again, we're just going to train you to do this. So, sine is cos, and cos is negative sine. Okay, so let's see, we want the integral of cos, so cos, that is sine. So that is sine x. Okay, and then that's just x to the minus 2. So we raise the exponent by 1. Okay, so minus 1 multiplied by the reciprocal of that new exponent, so minus 1 plus c. So that is now sine x plus, okay, so negative 1. There we go. So we have negative 1 times positive 1, so that's negative 1, and then x to the minus 1, so that's just x on the bottom, plus c. So there is our antiderivative. Awesome. So the next page, this is just a nice chart. So if we do this neatly, then we can use this coming up. Okay, so the idea is, okay, the most general antiderivative here. So if the function is just 0, okay, the antiderivative of that is c, right? Because taking the derivative of c, you get 0. Okay, if it's just 1, okay, we take the antiderivative of that, and I get x. Okay, because the derivative of x is just 1, so the antiderivative of 1 is x plus c. Okay, x to the n, so that's the nice little formula. So we raise the exponent by 1. Okay, so n plus 1, and times by the reciprocal, so that is timesing by the reciprocal, so 1 over n plus 1. That usually just pops out in front, plus c. Okay, so that's the raise the exponent by 1 multiplied by the reciprocal. Okay, then 1 over x, we saw that was ln, whoops, sorry. So ln absolute x plus c. Okay, so that happens when we have 1 over x. Okay, the derivative of e to the k to the x, so that is simply, okay, the integral of e to the x is e to the x, so that's just going to be kx. Now, remember, the chain rule kicks out a k, so we have to get rid of that. So we multiply by the reciprocal of k, so 1 over k, so really this is 1 over k e to the kx plus c. Okay, so that's getting rid of the chain rule. Cos kx, that is exactly the same thing. So the sine x is cos x. Cos x is negative sine x. Okay, so the integral of cos is just sine. So that's sine kx, and then we have to multiply by the reciprocal of k, because that's the chain rule part, okay, plus c. And then sine is a little bit different, because if I integrate sine, I get negative cos. So we're going to get negative cosine of kx, but again, we have the 1 over k to get rid of the chain rule part. So those are all our basic antiderivatives, and you can use this chart going forward. It'll be very helpful for you for the upcoming sections. Thanks, guys. Call me if you need anything.